Hi everybody, this is Shiva Biram. Welcome to the second session of electrical traction. In this session I am going to explain you the simplified speed time curve, trapezoidal speed time curve. In the last session we have seen what is meant by a speed time curve, what actually we are going to get from a speed time curve, and different types of speed time curves. All these things we have seen in the previous session, and in this class we are going to derive certain derivations regarding trapezoidal speed time curve. So here we are going to derive an expression for maximum speed, acceleration and retardation. As already we have discussed that in our traction applications, acceleration is going to be represented by alpha and retardation is going to be represented by beta. Both are measured in kmph/ps, kilometer per hour per second. All these units are very much important because all these derivations have been based on these units. So it is almost all mandatory for us to have the units of alpha and beta in kmph/ps. And here in this session we are also going to solve certain problems based on the trapezoidal speed time curve. Basically we have two types of simplified curves. One is trapezoidal speed time curve, another one is quadrilateral speed time curve. Here this one is going to represent the trapezoidal speed time curve considering time on x-axis and speed in kilometer per hour on y-axis. Time will be in seconds. Here, starting from the origin, if you consider the part 1 of this speed time curve from O to A, the train is going to accelerate and reaches maximum speed of Vm at point A or at the end of time t1. So here, if you consider alpha as the acceleration, the time taken for the train to reach the maximum speed Vm starting from 0 is t1 with an acceleration of alpha. So here we can have the equation for alpha as equal to Vm by t1 because acceleration is nothing but change in speed divided by time taken. So here the change in speed is from 0 to Vm within a time of t1. Hence alpha becomes equal to Vm minus 0, that is Vm divided by t1. Or you can also have the equation for t1 as equal to Vm by alpha. And from A to B, the portion is considered as second part, and here this part is considered as free running time. The time taken, the time of duration for this free running time will be considered as t2 here, and at B we are going to apply the brakes, and this is known as braking retardation or beta. The vehicle decelerates during this period, that is t3, and the portion is here part 3 of the speed time curve. And the initial speed here is Vm at point B here, and it comes to rest position at this point at the end of time t3. So here the time taken for the train to come from Vm to 0 speed is t3, hence beta can be expressed as Vm by t3, or t3 can be expressed as Vm by beta. So all these things are very much important when we go for the derivations. That's about the explanation part of this speed time curve. So the first part is acceleration part, second one is free running part, and third one is retardation. So let us derive an equation for maximum speed of this simplified trapezoidal speed time curve. For that sake we need to consider certain parameters here. D is the distance between the two stops in kilometers. So these units are compulsory, we have to consider in the same units that we are going to represent here. For example, if you simplify, when you solve a problem, if the distance is given in meters, you have to convert that into kilometers because the derivations we are going to do are based on these units only. And T is the total running time between the two stops, means the total time which is equal to the time of acceleration plus time of free run t2 plus the time of retardation t3. So t1 plus t2 plus t3 is considered as the total time, and that is in seconds. So here t is equal to t1 plus t2 plus t3, and alpha is acceleration in kmph/ps, kilometer per hour per second, and beta retardation or deceleration in kmph/ps. Vm is the maximum speed in kmph, kilometers per hour, and Va is the average speed in kmph. Vs is the scheduled speed in kmph. T1 is time of acceleration in seconds. T2 time of free running in seconds. T3 time for retardation in seconds. And here we consider one factor k, which is equal to 1 by alpha plus 1 beta. This is only for simplification process and nothing more than that. So k is considered as 1 by alpha plus 1 by beta. Now here first, if you find out the area of this trapezium OABC, this is going to give you so if you consider the area of this particular portion, this gives you the distance traveled between the two stops. Already we have considered the distance as capital D, and we know the area of a trapezium is equal to half into the distance between the two parallel sides, that is Vm, multiplied by the sum of the parallel sides AB plus OC. AB is T2 and OC is capital T. So if you implement that formula for finding out the area of this trapezium, that will give us the value of the distance traveled D. So here T1 is equal to Vm by alpha, just now we have seen, and T3 is equal to Vm by beta, and T2 can be expressed as total time. If you subtract T1 plus T3 from capital T, it will give you the value of T2, and D is the area of trapezium OABC, that is the distance traveled, which is equal to 1 by 2 into Vm. Vm is the distance between the two parallel sides multiplied by the sum of two parallel sides, that is OC plus AB, and we know that OC is equal to capital T and AB is equal to T2. So if you substitute OC for T2, sorry, capital T, and AB for T2, so we get the equation as 1 by 2 into, so here OC is capital T and AB is T2 multiplied by Vm, and Vm is expressed in sorry, the time is expressed in hours here because it is expressed in seconds. So the seconds are to be converted into hours because as we know that distance will be measured in kilometers, so kilometer per hour multiplied by hours will give you the distance in kilometers. So here we need to convert the time which is represented in seconds into hours. So we get here 1 by 3600 hours. 1 by 2 multiplied by 1 by 3600 will give us 1 by 7200, and we know T2 is equal to capital T minus T1 minus T3. So here substitute the values of the corresponding things. We get Vm multiplied by 2 into 3600 will give us 7200 into capital T plus capital T will give you 2T minus of T1 plus T3. So next substitute the T1 as equal to Vm by alpha and T3 as equal to Vm by beta. So just only I am substituting the values for T1 and T3 here, and once I substitute we are going to get capital D as equal to Vm by 7200 multiplied by 2 minus of, if you take out Vm as common from these two terms, we get Vm into 1 by alpha plus 1 by beta, and we know that 1 by alpha plus 1 by beta is K that we have considered earlier. Hence we get 7200 D. So if you cross multiply it, if you take out 7200 to left hand side, we get the equation as 7200 D is equal to Vm into 2T minus of Vm into 1 by alpha plus 1 by beta. So when you multiply this equation, we get Vm into 2T is going to give us 2T into Vm minus of Vm into Vm is going to give us Vm square into 1 by alpha plus 1 by beta. So here we can replace this one factor 1 by alpha plus 1 by beta by K. So we get finally the equation Vm square into K minus 2T into Vm plus 7. Okay, if you simplify the equation, we are going to get two values for Vm. Here A will be equal to, if you compare the parameters here, A will be equal to K and B will be equal to minus 2D and C is equal to 7200 into D. So substitute the values for finding out the roots of this quadratic equation. We get Vm is equal to minus B. So minus of minus, it becomes 2t plus or minus root of B square, that is 2t whole square, minus of 4AC. 4 into A is K here and C is 7200 divided by 2A. A is K. So that's how we get the value of Vm here. Plus or minus, if you take plus we get one value, and minus if you take it, you will get another value. Depending upon the problem that is given for us, we have to go for suitable value of the maximum speed. Generally we consider minus here. After that, let us find out another equation for this trapezoidal speed time curve. We know 1 by alpha plus 1 by beta is equal to 2t Vm minus 7200. That is, I am keeping k here and I am getting Vm square to the right hand side. So we get this one. And we know that Va is equal to capital D by 3600 d by t. Already we have seen this formula in the previous class. So from this equation we get the value of t as equal to 3600 d by Va, just as simple as that. And substitute the value of t in this equation, we get we are going to have this one 2 into 3600. So here instead of t we substitute 3600 d by Va. So 2 into 3600, which gives us 7200 into d by Vm into Va. So like this. And finally, if we take out all these things common, 7200 d by Vm square, if we take it as common, you get alpha 1 by alpha plus 1 by beta is equal to k is equal to 7200 d by Vm square multiplied by Vm by Vm minus 1. So this is another equation which is going to help us to solve the problems regarding simplified trapezoidal speed time curve. So here let us consider the problem number 1 based on the simplified speed time curve, that is trapezoidal speed time curve. So here we are given a train has an average speed of, so here the first you consider all the units in the same that we have considered in the derivation. So the average speed is given as 42 kmph, it is okay. On a level track, between level track means the track is not making any angle with respect to the ground, between the two stops of 1400 meters apart. So here 1400 meters, the distance is given as 1400 meters, so we need to convert this distance into kilometers. So this becomes 1.4 kilometers now. It is accelerated at alpha is given as 1.7 kmph/s, it's okay, the units are okay, and braked at retardation is given as 3.3 kmph/s. So everything is fine. Determine the crest speed. Crest speed means maximum speed over the run assuming the trapezoidal speed time curve. Sometimes the name of the curve will not be specified. Depending upon the data that is given for us, we have to consider, we have to assume whether it is trapezoidal speed time curve or quadrilateral speed time curve. From the data we have to expect. Now if you go for the solution, first of all I am writing down all the parameters alpha, beta, and the distance is given as 1400 meters. Convert that distance into kilometers, we get that the average speed Va is equal to 42 kmph. Time of run, so we know that the formula for Va is equal to 3600 d by t. So everything is given for us, we can find out the capital T from this from that equation. So d by Va into 3600, which gives us 120 seconds. So once we get the value of T, substitute the formula for Vm. Vm is equal to T by K plus or minus. Already I told you that plus is not going to be considered because the value of Vm becomes an unexpected value which is not practically possible. So T by K minus of root of T by K whole square minus 7200 d by K. So each and everything is known to us. T is 120, K we can find out from 1 by alpha plus 1 by beta. Substitute the values, you get the value of Vm as equal to, so just only substitution of the values, and once you simplify that you are going to get the value of maximum speed as equal to 52 kilometers per hour. So we can also draw the graph here, I mean the graph of trapezoidal speed time curve. So Vm is 52 kmph. Similarly you can find out the value of T1 using the formula Vm by alpha. So 52 by alpha is given as 1.7, so you get 30.6 seconds. Similarly T2, of course T2 we can find out later on because it is to be found out from capital T minus of T1 minus T3. So first find out T3 as equal to Vm by beta. 52 by beta is given as 3.3, so you get the value of T3 as equal to 15.02 seconds. And from this you can find out the T2 as equal to capital T minus of 120 minus of this 2. Here this 30 plus 1545, so you are going to get 73.6. So once you represent all these values, it will be the graph will be completed. That's how we have to simplify the problems regarding the trapezoidal speed time curve. So that's all for today's session. In the next session, I am going to explain you quadrilateral speed time curve and also some problems based upon the quadrilateral speed time curve. Subscribe to my channel, give your valuable feedback that makes me to make more good number of videos for you, and that is very valuable for me. Thank you very much for watching my videos. This is Shiva Biram signing off.